topic of this entire talk is essentially going beyond blockchain. And what we mean by that is the evolution of the distributed ledger from regular sequential blocks after block after block after block chain to this thing we call the Tangle, this directed acyclic graph, which is kind of like a multi-dimensional blockchain, if you will. So before we head into that, we should probably address the number one issue, and that is, of course, what is even a distributed ledger? So most people are familiar with at least a ledger. Like you can have a paper and you can keep track of notes there. You can keep track of different things there. And of course, you can hand that to someone and then they have that copy, but they have no guarantee that you haven't made a note. For instance, write down $1 on a bill and hand it to someone. That person has no way of ensuring that I haven't done that to 100 billion other people and essentially had created hyperinflation. So what a distributed ledger in this scenario does is that every single participant has a copy of the original ledger. So therefore, if I send Bob $1, then everyone in network sees that David sent Bob $1. Therefore, I have $1 less on my account and he has one more on his account. And there's no way for me to then send that dollar again to someone else, i.e. double spend. That is what that prevents. Of course, the same goes for data and other kinds of digital assets that you can represent. So it may also be useful to understand like the basics of networks. So of course, a centralized network is what most people are familiar with, where you have a big server that, for instance, hosts a website, and then all of these different nodes can connect to that centralized service, whether it be a website or something equivalent. A decentralized network is where you have multiple servers that may or may not connect with each other via this, and they have individual servers to themselves. But again, here you see, of course, you have these trust clusters, so to speak. A completely distributed decentralized network, on the other hand, is where every single participant is, essentially every single participant is an equal node. So they don't have to rely on one or multiple centralized or decentralized servers. Instead, everyone has the same copy, just like the same with the distributed ledger. So in the at least last 4 years that this space has been growing at an exponential rate, everyone has been talking about distributed ledger and blockchain as if they were interchangeable. That means, of course, that if you're talking about a distributed ledger, you have to be talking about a blockchain. But that is not true. Blockchain is a very specific kind of distributed ledger. It is not a universal one. It's not a generalized one. It's just a very specific way of doing distributed ledger technology. And this is very important because whenever you start talking about this, everyone just assumes this architecture, this blockchain architecture that we've all come to know and love and hate. Whereas the Tangle, what we have created, is also a distributed ledger, but it's not a blockchain. So I guess the best way to say it is that all distributed ledgers, all blockchains are distributed ledgers, but not all distributed ledgers are blockchains. And here you can see the difference from a topology point of view. And we will get into those details very shortly. So the big problem with blockchain, and the reason why this talk is called Beyond Blockchain, is these issues. So we will go over them. It's essentially 3 issues. The first one is the fee. As everyone has seen in the last couple of months or even the last year, the fees on blockchain is growing at an insane rate, which is not sustainable for any of kind of the promises that the blockchain gave us early on. The second problem is that of scalability, i.e. being able to actually use it at a large scale, which is also not possible. And the third thing is centralization. So we will go over these, beginning with this one, which is the fees and the slow confirmation times that the scaling limitations has. So of course, the way that a blockchain works is that each block can only contain a certain quantity of transactions. And that means that you have this very traditional supply and demand economy arise. So if I want my transaction confirmed, I have to up the ante. I have to add a fee that is higher than the other people trying to get into the next block together with me. And in the last few, I would say, weeks, we saw the transactions already go up to $15 per single transaction, which is just mind-blowing when you start thinking about way back in 2012 when I was getting into it full time, where the transaction fee was negligible and people were talking about how blockchain was going to revolutionize finance because you had no transaction fees. Whereas today you might as well use PayPal or Visa or any of those central service providers because they're way cheaper than the blockchain. And this is a very big problem that everyone is becoming aware of, but I don't think people quite understand just how severe it is, because people still talk about the blockchain as if though you could still use it for these use cases somehow in the future. But in reality, these fees are prohibitive. They make it impossible to use the distributed ledger for those kinds of applications. And the reason for that is what I like to call the blockchain bottleneck. So the way that a blockchain, of course, works is that you have decoupled validation of the network from the users of the network. So you have the users, and then you have the miners/validators. And like we saw on the last page, you can only fit a certain amount of transactions into each block. So as a miner or a validator, I only pick the transaction that benefits me the greatest because I have to carry out this very expensive proof of work in order for the block to give me the rewards and also reward me the fees that I collect. So this, as you can see, the demand is very high at the moment, and that's what we're seeing in Bitcoin and Ethereum in the last few months. And then, of course, you have this bottleneck because you still only have one block, and that's why you have these skyrocketing fees and very, very huge backlogs of transaction that has not gone through the network. And I'm sure every one of you that has tried to use the Bitcoin network or the Ethereum network during one of these high load periods have experienced just how expensive and how slow it actually is compared to pretty much anything. So how does it Tangle, the IOTA ledger, which goes beyond blockchain? Like, how does it differ? So here is a very nice way of visualizing the difference. So in IOTA, the more transactions that actually occur, the more demand that is actually occurring, the more validation is actually occurring. So you can see that the bottleneck gets stretched out. So there is no bottleneck in IOTA essentially. The more people use it, the faster it actually validates those transactions, which is the beautiful thing about IOTA. And I will get into how it works in a little bit, but just look at this image for a few seconds to try to see if you get kind of an intuitive sense of the difference. So here you can see it's a multi-dimensional ledger in the sense that you don't have this one block after block after block after block. Instead, you just have this stream of tangled transactions. And we call it a tangle precisely because transactions are tangled with each other. And that's exactly what we're going to go over here. And this slide, unfortunately, I didn't manage to finish those points here, but I will just walk you through it vocally instead. So in IOTA, the way the Tangle works is that when you issue a transaction, you validate two previous transactions. And of course, those two previous transactions, again, validate their own respective two transactions, and so on and so on and so on and so on. So these gray ones here, these gray transactions there, they represent the absolute most recent transactions in the network. These pink purple ones are the previous ones that have not yet reached confirmation, but have been referenced by at least some transactions in the network. And these green ones have reached finality, i.e. they have been confirmed. And the reason they have been confirmed is simply because the rest of the network here has referenced them. So there is no way for this transaction to be reversed, so to speak. And yeah, this is the third problem with the blockchain. This is the centralization issue that I mentioned. So even though blockchain has been told as this very decentralized and very like kind of the epitome of decentralization, In objective reality, it really isn't, because you have this incentive that we talked about earlier, where you have resources that need to be put in order for the validators to get their mining rewards and their fees, or the fee that they can collect in return, i.e. their incentive to even run a node and be a validator. So what ends up happening is essentially the people with the most resources to buy these mining rigs, these mining farms, they end up with all of the power of the network, so to speak. So even though Bitcoin and Ethereum is always talked about as decentralized and as distributed, like we saw in the previous slides, they don't really live up to that description when you look under the surface, because at the moment, a handful of mining pools control Bitcoin and Ethereum. And that is kind of it's the polar opposite of decentralization and distribution. So that is a very big problem in the blockchain architecture, and it is inherent to it. And that is one of the things that very few people seem to grasp thus far, is that this is not something that you can just change by switching some parameters or something. It's something that is inherent to the technology itself. So that is a major problem. So now that we've kind of gone through these three main problems, we can delve a little bit deeper into some of the unique aspects of the IOTA tangle. So again, talking about the centralization versus decentralization, if you look at the tangle architecture, because every single transaction references two previous transactions, that means that every single node in the network is an equal participant. There is no validation centralizations that occurs in the blockchain. In Tangle, instead, everything is maximally decentralized, meaning that there is no risk for like a 51 attack or something of that nature, which is actually quite a real threat to the blockchain. We've been in situations before in the past, and I'm sure we will be in the future, where mining pools have had more than 51% of the hashing power. Like one mining pool has had more than 51% of the hashing power. So it's not a good situation for the decentralized permissionless innovation to occur on such a backbone. And this becomes very, very important, or I should say relevant, when you start thinking about that we are living at the very cusp of a very connected and very autonomous realm, where multiple stakeholders will have businesses, they will send ginormous amounts of data to one another, meaning that they have to have a layer that they can trust one another with. They don't want to write a contract for every single delivery. They don't want to write a contract or go through all of the red tape for every single bandwidth they purchase or every datum they purchases. There has to be something, some decentralized distributed network as the backend. And of course, that is what the blockchain promised us, but it was not what it delivered to us. Instead, what it really gave us was a really good prototype, a really, really good prototype that kind of painted the vision for everyone. But at the end of the day, it does not execute on that vision. And that is what the IOTA project was born to resolve. So before I go into some of the use cases and some of the things that are unique to that aspect, I could tell a little bit about how IOTA came to be. So the entire IOTA project originates back to 2012, where all of the founders of the IOTA project joined and essentially got to know each other and was working on blockchain full-time in different aspects. And in 2013, we created the NXT protocol. So if any of those watching are veterans of this space, you probably remember the NXT project as one of kind of the first blockchain 2.0 platforms, where you could do things like decentralized voting, decentralized asset management, decentralized exchanges, decentralized marketplaces, these 2.0 features essentially. And it was also the first full proof of stake blockchain. And when we started thinking about the future, this right here, this 2017, when we started thinking about this, we realized that the blockchains that we had created and had worked with, they were simply not up to task. They simply could not scale or do anything to match the demand of billions and millions of devices that will be interacting constantly 24/7. So we had to come up with something new. And that was the original intent behind IOTA, or the motivation or catalyst, or whatever you want to call it. So again, we're touching upon this very beautiful thing here, that the distributed ledger promise of complete decentralization, complete getting rid of all of the red tape, all of that, enabling permissionless innovation, that creates this co-evolution. And for those who are into biology, this is exactly what happened during the Cambrian explosion, when we went from having just a few different living creatures in the sea to having this insane diversity. And that is kind of what we are mimicking with the Internet of Things in 2017 and going on 2018, with all of these different devices, all of the different machines, machine learning that communicates, all of this data being generated 24/7. But the problem again lies in lacking this ledger, this decentralized trusted ledger that enables people, or machines, I mean, to interact with one another without having to sign these cumbersome contracts, without doing all of those expensive things that makes most of it prohibitive in the first place. So yeah, this is the Cambrian explosion idea that we have for the Internet of Things, and what we believe IOTA essentially will enable. So let me see if I got the right slides here. Yeah, fortunately I do. So yeah, in order for this vision to come to life, the first thing that has to be in place is the incentive structure. We have to have a way to compensate. And of course, that's exactly what we've been talking about thus far. That was what the blockchain was going to give us, these peer-to-peer transactions without any intermediary, without any expensive fees. But unfortunately, the blockchain fell short of that. Now we have to pay tens of dollars in order to get a single transaction confirmed, which means every kind of microtransaction is completely out of the picture. So if I'm a sensor and I'm gathering data, I cannot sell that data to someone because it's just worth a few cents. But there are billions of us, these sensors. So it's a big economy, but individually at a fine granular level, you need to be able to send very, very tiny quantities of money. So in IOTA, given that we have no fees, we believe that we have resolved this issue. And that means that we have paved the way for this machine-to-machine economy, or economy of things, if you want to call it that. Because in IOTA, there is absolutely no transaction fee. Because, as I mentioned before, every single transaction that you issue or I issue references, i.e. validates two previous transactions, which means that you have absolutely no separate party. You have no miner or validator that you have to bribe, so to speak, to include your transaction for validation. It's just an intrinsic property of using the network. In order for my transaction to go through the network, I have to validate two previous transactions, but that means there is absolutely no fee that anyone has to pay. So if a sensor is to sell data to a computational station, it can do that at a sub-cent level if it needs to. And that opens up a completely new economy that has never existed before. And that is one of the most exciting things about IOTA. And of course, that creates these autonomous economic agents. So one of the best ways to think about this is perhaps a human-centric machine, which is a car. In 2017, cars are essentially just computers with wheels. It's what it is. You have more electronics and more computation under the hood of a car today than you have gears and any other mechanical thing. So with this distributed ledger, you can start to autonomize all of the different pieces in the car, all of the electronic pieces in the car with RFID chips, with NFC. You can start to create this autonomous maintenance. You can pay for these parts in like ahead of time, in predictive analysis of what will need to be changed. And that, of course, goes into the Industry 4.0 promise of being able to 3D print things on the spot and just put them into the car when they're broken, so on and so forth. And you can also, of course, pay for charging. Everyone knows that the future is electrical vehicles. Here in Norway, over 50% of the new cars sold are already electric. So that is the future we're going in. But in order to have the infrastructure to support all of these things, we need the car to be able to kind of be an autonomous agent where it pays for charging, parking, maintenance, toll stations, all of these things by itself, so that it becomes this autonomous interaction with the infrastructure that it inhabits. Same thing with digital twins. Digital twins, for those that are unaware, is simply a digital copy of the device. So in this instance, a car. So you would have a digital copy of everything in that car, from all of the microcontrollers, the actual equipment, all of that for maintenance. So you know in that digital twin when something has gone wrong, and therefore you can start to do this predictive and very cost-efficient ways of managing the car, do updates and so on and so forth, and also security, intrusion detection and so on and so forth. And of course, all of this fits into this permissionless ecosystem. That is the entire vision of IOTA, this enabling this permissionless ecosystem where you have solar panels that are selling their electricity to for instance, processors or storage containers or bandwidth containers, or the other way around. So it becomes this interoperable economy where the devices are completely autonomous. Another very important thing, which excites me perhaps even more than the transactional side of the IOTA ledger, is the fact that because it has no fees, and because it is completely trustless, you can have data immutability, and you can actually use the distributed ledger to transmit data. And as we touched upon before, the entire purpose of a distributed ledger is, of course, that no one in the network can alter the data or the transactional data after it has put into the ledger. So this opens up a completely new realm of trustless, both business models, but also just security promises, so to speak. So I think we have an example here, for instance, where this is something we're doing together with BOSCH at the moment, where we secure sensor data from this machine, which then is sent to the cloud via this module that we have called masked authenticated messaging, which I don't think I will have time to go into here, but I can share a link afterwards. And of course, then from the device itself to the cloud, the data is put onto the distributed ledger, the IOTA ledger. And when it arrives at the cloud can verify that indeed the data that it has received is the same as was sent from the device, and vice versa. So when this machine is to receive, for instance, an update, it can verify, okay, I have received the right copy. I can trust this download. There is no malware in here. And that creates a much more secure realm than what is currently the case. And of course, in a world where everything is connected and data is flowing back and forth all the time, and machines are making autonomous decisions based on data, this will be insanely important to have that data integrity ensured at all times. And again, the blockchain can do it in principle, but not in execution, because of the limitations on transactions per second, because data transmissions are again just a transaction, just the same as a transaction, and also because of the fee. It's just simply too expensive to send data continuously if you had to pay $15 for each data packet. Like, no one would be able to afford that. So here again, the economy of things is what we're describing here. This interchangeable realm where all of these different devices are trading with each other, whether they're trading data, whether you are getting footage from a drone, or you're buying weather station data to make more and better predictive analysis of the weather, or you're buying bandwidth, or whatever it is. All of it goes again into this IOTA ledger, and the IOTA ledger then acts as the catalyst of everything here. And of course, it's the same thing with access management. As we're moving into this sharing economy 2.0, 3.0, 4.0, whatever you want to call it, people use all different terms for this. But what is clear is that we have Ubers today, we have Airbnb today, and the next kind of phase of that is being able to rent out any kind of equipment you have, or any appliance, or anything you own. the entire concept of ownership is changing with this new model. For instance, with cars, they are stationary in your garage for like 97% of the time. So why shouldn't they be out making money for you if you own it instead? Same thing with your drone. You're not playing with your drone or using your drone all the time. So why shouldn't you instead just rent it to someone that may be using it when you're not using it? And your, of course, tools and everything else. With the distributed ledger and an identity protocol on top of that, you have the recipe to create this sharing economy 3.0 or 4.0 or whatever you want to term it. So that's also a big human-centric application that we see a big future for and are working with several big corporates on these kinds of models right now. So here are some of the examples that kind of touch upon what I've already said. This is what we're working together with Volkswagen Energy and BigChain DB on, securing the data from the vehicles. Because of course, like I said before, cars today are computers with wheels. So you don't want people hacking into them, turning off the brakes, giving false machine learning sets, creating artificial insanity, and so on and so forth. You don't want that. And that is exactly what a distributed ledger can prevent by ensuring data integrity and the access management of that. So we are very happy that we are working with these great partners on making this a reality already. And I want to again underscore that all of this is occurring on the public ledger of IOTA. So we're not doing this as a private instance, as we've seen a lot with blockchain. We're doing this on the live distributed ledger because the IOTA ledger can actually scale and it doesn't cost anything to use it, unlike Bitcoin and Ethereum and all other blockchains essentially. This is another very cool project that is going on right now with Nexus and ELAD in the Netherlands. That is e-charging, which I also touched upon earlier, where of course the car pays for charging in real time in streams of IOTA. So that is really, really cool because that incentivizes the infrastructure needed for the electrical paradigm shift that is happening in the automotive industry right now. Again, we're doing this together with Energy as well in this project called Oslo to Rome, where cars are essentially going from here in Norway down to Italy, and throughout Europe, they are relying on exactly these kinds of charging stations that are being paid entirely in IOTAs. So that's another real world use case that is really cool. Another big thing we have on the horizon, which is very close, is a data marketplace. So I'm not at liberty to disclose exactly which partners we have involved in this yet, but it's quite a lot of big players. And again, it's because of the game-changing factor here that you're able to take data and monetize it. Because today, 99% of data, and that's not an exaggeration at all, it's more like 99.9% of data, goes completely lost to the void. It's generated and perhaps acted upon once or twice, but then it just gets discarded. And the value that was in that data is never shared with any other stakeholders, simply because you have no way of doing it in a secure way today, where you have data integrity ensured, and there's no way to do it in a easy to monetize way because of the transaction fees and the scalability limits that we have already talked about. So this will be a really cool use case, and it'll also be open for everyone. So you don't have to be a big conglomerate like BOSCH or Volkswagen. You can be yourself, and you can have like a weather station sensor that is gathering wind data, temperature data, humidity, etc., and you can then put that on this data marketplace and monetize it, and then use the distributed ledger for both the transactions as well as the data integrity and the data streams. So yeah, that's essentially what I managed to fit into this. But yeah, if you have any questions, especially in regards to like how the blockchain is different from the Tangle or why it is important, just feel free. So Urosum, you're asking how to enroll for the data marketplace. So the data marketplace will be unveiled very shortly in quite a big fashion. So all of the data will be made available then. But it will be very easy to participate. All of the APIs, etc., is very simple to interact with. So how does the verification setup work if there's it's not one true version of the ledger? Is it split ad infinitum? Yeah. Okay, so I'm not entirely sure what you're asking. In IOTA, you have a ledger that is distributed among all of the participants of the ledger. But unlike a blockchain, you don't enforce a omni-state at all times. Instead, you have eventual consistency. So that in order to answer that in a more detailed fashion, I would have to go into the cap theorem. So of course, the cap theorem states that you can only have consistency, availability, or partition tolerance. You can only have two of those at the same time. In IOTA, we have this partition tolerance and availability at all times, and then eventual consistency. And that is also how we prevent the network from being attacked, because you would have to have this omnipresent state of the ledger and interact with it, which of course is completely impossible. Like even physics tells us that that's what special relativity is all about. You can't have omni states. So yeah, that's how the Tangle works differently from a blockchain. That's also why it's a lot more efficient, because the blockchain has to wait for the entire network to converge right away on every single transaction. Yeah, so Urosum, you're asking, the cost of a transaction is at least to make two previous verifications. Yes, so essentially you're sending a transaction, and in the process of doing that, you are executing this Markov chain Monte Carlo random walk algorithm, this tip selection algorithm, which selects randomly two previous transactions in the network that you are to verify. And those two have verified their own two, and so on and so on and so on. So you get this compounding security. And the cost of that, just to answer that very briefly, is absolutely negligible. It's not even measurable. I remember doing the calculations based on smartphone consumption, and it's like 0.00000000001 cent or something. So it's free for all practical purposes. I just want to say thank for me, and hope this elucidated some of the questions pertaining to IOTA and the blockchain itself. So feel free to just go to the Slack or ask questions on Twitter or something if you have any further things that you want to know.